Okay, good morning again now. Now in the previous class we have studied about the Ohm's law. Now today we'll be studying about the experimental verification of Ohm's law. Now for the experimental verification of Ohm's law, what we need the experimental verification of Ohm's law, we need 4 cells of 1.5 volt each. We need a voltmeter, obviously, to measure the potential difference. We need an ammeter to measure the current flowing across the conductor. We also need a resistor. Resistor over here is actually a nichrome wire. Now, nichrome is actually an alloy. It is an alloy which is a combination of nickel, chromium, manganese and certain metal irons. Okay, now this nichrome wire, now in this experiment we'll not be connecting all the 4 cells all together, we'll be gradually moving. Now the circuit diagram for this would be, we have this battery of 4 cells, then we have this resistor, and as we all know that voltmeter is always connected in parallel. So this is a voltmeter which is connected in parallel to it. Then we have an ammeter which is connected in series with the resistor. We have a key and this is it. If we have to give the direction of current, we always know that it's from positive to negative. Though internally it is from negative to positive terminal. So this is the direction of current. This is positive, negative, and negative. Now, how we will be proceeding with this experiment? In this case, initially we have 1 cell in the circuit, okay, and then corresponding to it, we make a table in which we have number of cells, then we have make it. This is number of cells in the circuit. Then we have this voltmeter reading. Then we have this ammeter reading. And resistance R, which is the ratio of V and I. Initially we have this 1 cell in the circuit. Corresponding to that, we note down the reading of voltmeter and then we note down the reading of ammeter and we calculate the ratio resistance R, which is the ratio of V and I. We get certain reading. In the second step, we have 2 cells in the circuit diagram. Now after putting 2 cells, we note down the voltmeter reading corresponding to it, we note down the ammeter reading corresponding to it, and again we calculate the resistance R, which is the ratio of V and I. In the third step, what we do is, we proceed with 3 cells in the circuit, okay? Now when we put 3 cells, we note down the corresponding voltmeter reading and then the corresponding ammeter reading, and again we calculate the ratio of it, that is resistance R. In the last step, we have 4 cells in the circuit diagram and we note down the corresponding voltmeter reading and the corresponding ammeter reading, and again we calculate the resistance R. This is the procedure for the experiment. Now what is the conclusion? What we conclude is that every time when we increase the number of cells, or if we may say that, in the first case when the cell was 1, we have calculated certain value of R, which is the ratio of V and I. Second case, when we had 2 cells, we again calculated R. In third case, when we had 3 cells in the circuit, we again calculated resistance R. In the fourth case, again when we had 4 cells in the circuit, we calculated resistance R. So what we concluded was the resistance R, or the ratio V upon I, in all the cases was same. That means R was constant. As voltmeter, that means R was constant in all the 4 cases. So if we have to plot a graph for the same, or we may say if we have to calculate the ratio R, so when we plot the graph, we get this kind of graph, and which is a straight line inclined to the x-axis. Now in our lab, we have this kind of experiment, this kind of apparatus, which proves the Ohm's law. In this case, we see that gradually when we are increasing, we get a certain value of I. Again, for the second set of reading, we are increasing V. Again, we're getting a second set of reading, which is I. Now, in this case, we take 4 sets of readings. We calculate the resistance R, which is the ratio of the two, and we plot a graph, and which we see that the graph is always a straight line, which is inclined to the x-axis, and hence this is what verifies the Ohm's law, but on a condition that the temperature should remain constant throughout. Okay.